Well, folks, this is something slightly different. It's one of our sets, so we try and alternate between a customer repair and one of our sets. Oh, this doesn't bode well. It's already missing its switch. It's an immaculate SMC Oscar 2, otherwise known as a CBM272. These don't use a conventional synthesizer, it's a Motorola general purpose one, and it was very, very easy to turn these into a 28 meg ham set, and a lot of them got that treatment, but most of those that got that treatment, the person wasn't able to implement the modification properly, and so it's not often you see one that actually works. In other words, they've been ruined. So I think this one's come from Alan, so thank you, Alan. I'll tell you what I'm going to do. I'm just going to verify that. Yes, from Alan. So that's, and he also sent these 2.1mm leads, which just need fuse holders popping onto them to make them useful for things like emergency sets. So thank you once again to Alan, our mystery benefactor. So he probably ended up buying this and then finding that in fact it had the screwdriver expert. I'm sure I'm going to be right. I may not be able to fix it. Yeah, right. Now, unlike the SMC Oscar 1, the one with the tiny meter, these are comparatively bleed over boxes. They're a bit like the Murphy DS602 and the JWRM2 and the ICOM ICB 1050. Now, please take note, the ICOM ICB 1050 is not made by ICOM, as in who make ham radio equipment and marine radio equipment. It is just, they've just pinched a name. It could say Mickey Mouse on the front for all it matters. And you see these going on eBay. I think there's one right now and they want like 65 quid for it. But if I tell you they're £19.99 new, you know, that's the kind of quality we're looking at. And these were only £49.99 new, even from SMC. Let's see what horror awaits us. There's two 4001 ICs. It even says SMC Limited on this. Anyway, we'll power it up. I don't know what mic these take. What I'm trying to see is if this actually works as it's been modified. It lights up, go to 13.8 volts, and it lights up even more. So we've got these stray wires. Chances are that those stray wires once went to that switch. And is it a tone for accessing a repeater back when you had to have a 1750 tone to access repeaters? Alright, well, instead of plugging the test instruments into the external speaker, we'll plug our speaker on the wall into the external speaker. Then if anything is not right, I'm not blowing up my test instruments. So without a mic in, we've got an FM hiss. But at least it proves the FM bit works and the audio amp works. I just don't know what the mic is, but I'll tell you what, we'll plug in. Well, that sends it into TX. Doesn't transmit, of course. Right. So you need two signal generators to set one of these up. It's one of those where we've got to set the transmit, we've got to set up the master oscillator 10.24, we've got to set up the receive, we've got to set up the transmit. So it's not an easy thing to do. So we've got to put this wiring back right. That might involve me taking a set off the shelf. Let's just get these wires out from here and we'll clean it up in a moment. Not sure about that pink one. Let's get rid of that. Right, well that's got rid of the board with the two 4001s on. So all we've got to do is to thread these back through those holes in the right order. And that will be interesting. I think our best bet is to see if I can spot another one on the shelf and copy it. Okay, so I've done that. So we're back with you. I found a JWRM2 and luckily it is identical because they're not all identical. I did mention the fake Icon brand one and that, but this is identical. So I've taken off a load of extra capacitors which have been shoved on because we can see this has been on 29 megs and all the coils are right out of the top. So we may as well go down a lot of the cores and actually get them flush so we've got a fighting chance. Now when you look at this, I've got a coloured ribbon cable there and we've got an ordinary wiring harness there. These are in sequential order, so the yellow wire there is next to the pink wire which is a permanent arrangement. So the pink wire is still the permanent arrangement, goes to the channel selector there. So it is sequential, but when you get to the last two, in this case it's grey and white, in this case it's violet and blue, they actually transpose. So when you get to this point, it's all sequential right the way down, 1, 2, 3, 4, 5, and then those two, 6 and 7, they're topsy-turvy. It's like it's a printed circuit cock-up. Anyway, that's how it is on that, so I've no doubt it is on this. This is a set we'll do in the future. It's one of my own sets I've bought, but I've no reason to believe that, although it's a non-worker, because Mark's written on it that it is, it won't be because of this. I also found a cracked track, which may be why this has been discarded. I'll be going over this with isopropyl alcohol, but where that pad is that goes to the wiring I've just done, that is actually given way, so I've linked that across. There's loads of capacitors on the bottom and there's loads of other extra parts. We're going to have to make, there's been some cuts as well, so we're going to have to put back some, there's a cut there you see. It's only my own set, so we'll just put a solder logic across that right now. But if it was a customer set, we'd be doing it with a wire link. We'll probably end up doing it with a wire link with me as well. think part of this is because they've got it permanently on 4 watts. We're going to have to find out and see if we can find a switch. So put that on one side. Okay, so we've got it back on. It's lit up. We're on channel 20. I'm not bothered with the mic. I've got the signal generator on, and I've got full whack channel 20 2779125. So without getting the test gear on the go yet, and assuming this is kind of right-ish, we'll get all these flush, so we may have a fighting chance with the VCO. Well, look at that. Good. So I'm not going to worry about the missing switch at this point, simply because quite clearly it's going to have been transmitting at full 4 watts. The switch will have been used for something else, so it'll have been linked through, I'm absolutely sure, to transmit on full power all the time. I'd like to reinstate that. It's taken an awful lot of time even just doing this, and having another set to hand to follow the wiring. Right, we'll get my mic plugged in. Still not assuming it's Cybernet, but I wasn't always sure. I'm going to get my monitor receiver on. Just because it receives doesn't mean it's ever going to transmit. Oh, we're on key lock, are we? So we'll turn the signal generator down, pop the squelch on, key up. 1 2 1 2 1 2. Well, there we go. It is actually transmitting. What we're going to do at this stage, because there isn't enough power coming out of it, even if the transmitter works on it, is I'm going to go through the transmitter stage, what I believe to be the transmitter stage, and we're going to actually, at this stage, we're going to go for maximum current consumption when I'm in transmit. At the moment we're at 298 milliamps. I'm being very careful. These still could do with being eased off a bit. I can't believe I've not got an instruction book on file. That doesn't look fiddled with. One, two, 1 2. We're still not getting enough. I don't even know whether that's part of it. That could be a doubler in that chip. Check I've still got receive. Yep. Let's have a look at where they are on this one. Well, that's definitely lower down than that. I may have to dig a circuit diagram out for the JWR. I will have that on file. Well, that's now coming through the monitor receiver. I see the coil in that, and this is a polythene, so I don't really want to melt it with a soldering iron. Doesn't think that's been touched. It may be that the transmitter doesn't even work on this. I would have thought that I'd have got them somewhere about. Oh, I'll tell you what we'll do. We'll go on to receive and just get it somewhere where we can get some readings. I'm not filling a before and after sheeting, because with this having been turned into 10 meters, it's obviously been effectively disabled, or you could even say scrapped. So I will get a sheet out when it's working, but we can't be jotting anything down in reality. So go back to receive. I don't expect much cleverness with the squelch on these. It's pretty weak and watery. Right, so we'll now swap that for the test equipment speaker, going into our SINAD meter and our oscilloscope. So that's 100 microvolt equivalent. The meter wasn't moving at 100 microvolts. So at the moment you're listening to 10 microvolts. I'll put picture in picture on. And we'll go down some of these which have obviously been shifted a long way. Three microvolts. It's now bringing us to a SINAD of 0.55 microvolts. So I've not got the right meter on, have I? So there we've got 12 dB SINAD, and there we've got the attenuator on the 1 and just over the 5 there. So it's already working very well on receive without going anything further. The detector on these are the two of them. It's different. I'm sure it's different. Let's go to the oscilloscope. So where's the detector likely to be? Well, we've got an MC3357 there. We've got a coil there full of wax. It's probably actually spot on, and it's been wax sealed. But I will just verify. Actually, it wasn't quite right. That wouldn't have been affected by the modification. We may as well seal it back up again. Then we've got the IFs, which really shouldn't have changed. Just check those with the... I'll just put a big signal on. We've got to set the frequency yet with the second signal generator. I can actually do that pretty pronto. What am I going to do? Put the... Yeah. That's a pretty sharp adjustment. Not sure what that one is. As we have it at the moment, don't know whether this affects receive as well as transmit. So I'm going to get the second signal generator on right now. We'll just put this on to a blank carrier. I think there's something wrong with the transmitter on this, to be honest, but it'll be tomorrow when I move back onto it. So it's going to have taken 2 days of sessions, which means I can't get on with paid repairs, and that slows up customer jobs. I try and make these so that they can be done in 1 day, but this is beyond what I can do in the sessions I have available. And as I'm doing this, it's now 7:30 in the evening. So we've got 10.695 there on the secondary signal generator, and you can hear that musical note. One of these two crystals is for the receiver. Not that one. There we are. We have nullified that. What we haven't done though, we've done this topsy-turvy. What we haven't done is check that that's 10.24. Because if that isn't 10.24, I've just wasted my time. Let's just see if we can put a probe on the... I don't seem to have got any BNC leads on here. What I wanted to do is to read this crystal. It doesn't look like we're going to be able to do that. So that's going to have to... We'll have to come back to that tomorrow. I'll have to find out where all the BNC leads are. So we're now on frequency. It's nice and sensitive. And as far as that goes, I think we've tuned up the receiver. I might just check those. But just to tell you what we've got right now, that's before I knock the signal generator off frequency. So that one's receive and that one's transmit, and that's 10.24, which you do first. So just to tell you what sensitive we actually have got, it's actually 0.65 microvolts for 12 dB SINAD. So it's not as good as it will be, but it's certainly adequate. It's better than that magic 0.1. Right, we're going to have to get the circuit and probably probe. I did notice there was the possibility, just turn this power supply off, there's the possibility that there's a cracked track I did just spot it there. But if it was working as far as there, I'd expect it to be drawing a lot more current. So at the moment I'm not overly concerned. I'll tell you what we will just do as a final thing before having to get the print off the instruction book for the JWR. We'll just get this on and just see if we've actually got any RF up to the driver transistor. Because it's quite possible it's knackered. Power back on. So let's have a look. We should have more than that. It's not coming through to that point, but it should be on the maximum on this. It'll probably be full scale deflection. So let's go up a scale and just see whether we can find where it's gone. See, we've got more there. Just have a final twiddle here. I'll just go to the main meter just in case it suddenly starts transmitting. No, it's something amiss, so we'll look into that. It could even be down to a previous stage transistor, but I'll get the circuit and we'll see what's what. So we'll come back to this tomorrow. We'll switch off for now. I'll tell you what, we've kind of got 4/5 of it. Right, so the next day we have actually got some transmits. Took both the driver and the output transistor out and tested them, put them back in, and I've just gone through the coils even more meticulously, and we now do have transmits. It was quite simply, so far as for alignment, and it's now doing 500 milliwatts. So that's a head in the right direction. So let's see whether we can actually line this all up, or whether we're going to fix it worse again. So that's our definite point. 1 watt. 2 watts. Go back on that one, check that one. .3 watts. Just check them all again. Two and a half watts. We'll move over to the PA. It's got the wrong PA transistor in. It's got a 1306 instead of a 2078. I don't know whether that's because he wanted it. I don't know whether that does more power or just it failed and they put something else in which will do. There we've gone beyond 3 watts. We've changed scales. The 3.1 watt, 3.6 watts, that's about where we are, 3.8. So just run through these 3 again. That's actually 4.2. This is all interactive. You've got to go backwards and forwards. 4.2, and we'll tune down for 4. So there we are, 4 watts. Well, good. I don't need to really tidy these up because I don't think they should have wax in them anyway. Have a look. Oh, they have got wax in them, so we will tidy them up. There we are. So I found also that there's an orange wire, no, yellow wire. That's our low power wire, and the high power wire is the orange one. So there's a red wire goes to the high-low power switch, to the on and off switch, and then the high power wire is the orange one. The low power one is the yellow one, but we'll do all the tune-up first, and then we'll see whether there's any switch which is compatible that I can actually fit in there. Now what I want to do is this 10.24. So looking at the circuit diagram, which we now have, by the way, I did a blow up of the transmitter to help me with the alignment. So this is a scan of the instruction book for the JWR. We've also got on hand the icon. None of them have got board layouts. I haven't got an SMC instruction book. Perhaps it's better than these. These are very good, but it could do with board layout. So having done that, where are we going to find this test point? There is a test point on pin 7. I don't think that's going to be what we're looking for. But you know what? Let's get the little oscilloscope out and use that. So put one end of the chassis. So don't need to be in transmit. So pin 7 of the phase lock loop chip. So pin 1, 2, 3, 4, 5, 6. Well, this test point, let's see what it has on it. I think we're best off putting this on with a crocodile clip in case my fingers are inducing a hum. It's probably the output, to be honest. .0 change channel. Yeah, well, it's not what we're looking for. So I think we're looking for pin 4 or 5 to do this. So what I need is something to use as a little prod to get onto the pins. I'm sure we've got a ceramic, not a ceramic, a phosphor bronze tool on here. I'll use this small screwdriver. I don't want to be wasting time. I just want to get on with it. 1, 2, 3 and 4. I've done my accounts over the last 3 days and I've submitted the tax return, and it's just one of those time wasting things which, when I'm doing that, I'm not earning any money. So it's not that pin. Not that pin. How can that be then? 4. That's across 3 or 4. Wow. Let's see what we've got on the trimmer. 14.0. Where on earth is the pickup point for that? Well, it disappears also to pin 1 of the MC3357. .2365. It won't quite go. It's 10.2391. So that's going to send the IF very slightly lopsided, but that's as close as we can get it. It's not going to matter. So now we'll reset the receive. So we want 27.79125 on the test set. So we'll put this frequency counter up. 27.79. There we go, that'll do me. Turn the carrier off. We'll get the little signal generator once again, like we did yesterday, and we'll now set this properly. It's remained actually on frequency, so it hadn't affected that. So you can make sure you can hear this. So it's right in the centre of the null. So we now know it's on frequency. That's set to 10.695. We know we've got the 10.24 as close as we can get it. And now all that remains is to set transmit frequency. So leaving that on the display, let's key up and see what frequency we've got. 27.79089. Not bad. I'll tell you what, it still pulls up. There we go. That'll do me. So we'll just finalise the receive and then we'll start faffing about with the presets. Signal generator back onto tone. Put the C oscilloscope on. I don't think the detector will have changed. Because the IF feed was wrong, it could have changed. That's why I have actually just adjusted that. It was slightly to one side, so it was more off frequency than it is now. I say it's 10.238 something, not 10.24. Just means that the maths is slightly wrong and it's going to be very slightly lopsided, but the filtering's such that it's going to be wide enough. It's not going to sound silly at all. Anyway, who else goes to all this trouble? So be clear, transmit, receive, you do the 10.24 first, and we could only read it for some reason off pin 1 of the MC3357. So when you look at this, it's supposed to go, there's pin 1, goes through that coil, 203. So we should have been able to read it on pin 3 of the phase.loop, but for some reason I couldn't. Perhaps if I'd actually got better probes, I would be able to. So I think if we adjust 205, is it? Is that going to be IF injection? 204. I think it's 204. The trouble is, I bet it's that one, isn't it? Which nobody's ever. I bet it's that one that nobody's ever touched. I bet it is. Just see if I can get a reading on anything. Yeah. So it does affect the receive. There's the SINAD meter. So if I take it, soon can go right off. So that's IF injection. No wonder I couldn't see what that was. So we'll just check once and for all that we've got the alignment as good as we can. These are very, very fine. Got an IF1 there. Just check that. Probably need a bigger signal for this one. I'll try it with a bigger signal. So the instruction book says this radio will do better than 1 microvolt, which is exactly what the instruction book said for that brand new Moonraker micro we did the other day. So sensitivity is, well, it doesn't even say better than, it says it is 1 microvolt for 10 dB SINAD. And for 10 dB SINAD it is 0.59. I'm going to jot these down after tea. So what can I hear down to? About just beyond 0.3. So have a look at the specification. It's supposed to be 1.5. Let's see what current consumption is and make sure I'm in transmit. It's 1.28. Let's see where we are. Transmitter. It doesn't actually seem to say. Works from 10.5 to 16 volts. Squelch range is 1.5 microvolts, which is absolutely lousy. As weak as dishwater. Right, well, see if we can find what some of these presets do. Well, that's going to be low power when implemented, the fact that that wire goes to it. So we're going to have deviation, the 2 meter adjustments, and squelch. I wouldn't be surprised if the 2 meter ones, and that yellow wire looks like it goes to transmitter, so I would think that's going to be the transmit meter. So we'll key it up. Should be centre of the red zone. Meter's a bit sticky, but nevertheless that is the centre of the red zone. So I was right there. So let's look where the S meter is. I'll tell you what, it's nearly spot on. It's going to be that one, isn't it? There we go. 100 microvolts. So deviation, we'll use this test setting at this point and we'll verify it with the one behind me, just in case it's lying. Wallow. Because it's going to be very wrong having been converted. Wallow. It's not that one. Surely that one's squelch. Wallow. Well, it isn't. So that's deviation. So that must be squelch. So we'll put a signal on the radio, put 100 microvolts on, turn this down till we can hear it. No. To be honest, no, he's on the verge of never opening. We've actually got 4 microvolts. The book says 1.5. I've therefore got a better result than they have. At the sensitive end, and this needs spraying, at the sensitive end, if we put that to standby, it's about 0.85. Anyway, we'll get a sheet of paper and we'll go through those. So we've done it. I've just got to see if I can find a switch from somewhere and if I can re-implement the high-low power switch. So I've surpassed myself on this one, and thanks to Alan for providing it. Because other than what's happened to it, it's in reasonable condition. Knob missing, that's clearly the wrong one. Right, we'll put some service oil on this potentiometer. The volume one's alright. Something about LED shows in modulation. Wow, it doesn't. That's a load of codswallop. I expect there's an AM version for America, and it does on that one. Mod TX lamp. No. That's bull. Nice comprehensive manual on this, the same with the fakely named icon. This will glow green on receive. Perhaps it does on the JWR. No, it doesn't. It's just the same. It's got a red LED. Bull. Absolute bull. Right, that's what we're going to do then. We'll just see what we can find to fit in there. Pop the mic off. I'll pop the soldering iron off for now. I've had the spectrum analyzer on, but that was fine. I'm not going to bother showing you that. And we'll just see if there's something I can do about the missing switch. So a lot of work to bring it back. This isn't going to be easy because the mic socket is on the front panel. There is enough for us to get by. Now, you see a lot of these sets scrap, but I don't think I've got any in here, and it's going to be our only chance of finding a switch. So pause the video. Right, I'm back with you. Found a switch on. I'm sorry it's a scrap set, but that's how I bought it. It's a Eurosonic Euro 1. You don't see a lot of them, and I bought it like that, but I've now had the switch off it. So that is now there, and we've just got that to set up. I've just dropped the lid off that. Just put that back on with the power off. So we just need to colour in. I've got my wax crayons. So not a cheap task in time. That's going to be low power, and that was transmit, and that was deviation. Oh, and that's transmit. So the frequency control side of it is 10.24, which is done first, and then receive 10.24 into the receiver, detector squelches there for what it's worth. Now, where's the pen gone? There it is. So, TX, RX, 10.24, 10.24 to RX, detector low power, squelch, RF meter, S meter. We'll do one of these again in a few weeks. I would have boxed one of these. That doesn't mean it's immaculate in box. It may be a knackered one, incomplete and boxed, for all I know. But we've got two of them on the shelf. I've just got a feeling that the transmitted audio on these is exceptionally good, and they did have a bit of a bleed over reputation, but those days have gone. Right, so we just need to now, I better make a note of what this is, what set this is, because I haven't scanned it yet. And it is the SMC 272 Oscar 2. So we go to the previous page, and what we need is a sheet of paper. Okay, so finish this off. Switch the set on, and we'll just put in a few of these things that I haven't already guessed. So we're on channel 20. We know it's doing 4 watts, but is it doing 4 watts on the other channels? It's doing 4 watts on channel 1. And it's doing 3.9 watts on channel 40. Right, high-low power. Of course, I've fitted this, so we've got to start from scratch. So select low power, and it's nothing. It's that preset. The preset's fine, and that's down 400 milliwatts. That was flawed. I did this on channel 40 by mistake. So we'll check that again. Still the same. Current consumption is now 1.28 amps. We know that the transmitted audio is 2.2 to 2.5. I've done it on the test set behind just to verify it was right on here, and it was today. Frequency, let's go over to the frequency counter, because we're now 2 hours later than when I set it. 79131. And so remember, I've got to get this into you. 10.24 first, then transmit, then receive. Receive has to be done with a second signal generator at 10.695 or 455 kilohertz. Right, let's move on to the receiver. So we'll put the SINAD meter up on the screen, and we'll switch it on as well. So it's actually 0.62 I've now got. For 10 dB, 0.55, actually 0.555 to be honest, and for 20 looks like one. I'll just go up a scale. 1.05. That's where the letdown is. Squelch threshold. At 0.55. And squelch maximum. That's gone out of adjustment. How annoying. Right. It's 2.5 microvolts, which is really wishy-washy. If you lived in a town, this radio is useless to you. But just to go back on what I said earlier, squelch maximum says 1.5. Well, I've managed to get 2.5 out of it. So, honestly, it's what they thought was right. I don't. We've already got 4 watts. We've already got 100 microvolts because we know it is. That's it. We're done. So, it's very much kind of Mr. Average on the receive sensitivity. It's not deaf. It's not super sparkling. Lots of sets do round here. Anything under 1 microvolt is fine. The instruction book says 1 microvolt. It doesn't say it's better than 1 microvolt. It says 1 microvolt for 10 dB, and we've got 0.555. So I think we've done a good tune-up on that, and I've also done well. So I get some brownie points for actually turning it back from what otherwise would have been a scrap set on 10 meters and no longer working. So I need to just pop the power off because I need to take my crocodile clip off the innards. I doubt it's had that much use, to be honest. So get these smouldered back on. That's like soldering but with smoke. Different pronunciation of that word in America. Soldering. I'll be annoyed. The speaker's no good. Power back on. Oh, of course I've disconnected it, haven't I? So I'll put that on loosely for now. Unplug my extension speaker. Shove that in the appropriate hole. That sounds fine. We'll get some screws in it. Now let's put it on the aerial and see if there's any good or bad buddies, and see if I get a Roger like I did the other day. I don't think I will. About 1 every 50 calls, isn't it? So I'm sure Alan will be pleased to see this working. Switch picture in picture off. One on a Roger. They're all having their tea. It's 6:30. 19 a Roger. There's a bit of a voice out there. So, rubbish squelch, but I've got it set better than they say. I bet that made a noise on the mics as the peak meters went for a little walk. Thanks for watching the SMC Oscar 2, otherwise known as a 272.